Okay, folks, this is the second part of the lecture we started last time on rational expressions, and this time we're going to be talking about the addition, subtraction, and equations involving rational expressions. So what we were doing last time were multiplication and division, and of course we were also dividing polynomials as a part of that lecture. Okay. So how do we add rational expression? Well, we add them exactly the same way we add fractions, which means if we have the same denominator, we just add the numerators. If we don't have the same denominator, then we have to find the common denominator, and it's usually in a way that we are finding the least common denominator, the simplest one, and then we build up both fractions we are adding or subtracting. We build them up to the common denominator, and once that is done, then they have the same denominator. We can just simply add by adding a numerator. So you have to be a little more careful when you are subtracting, because you have to subtract numerators rather than just the sum terms. All right. So here's an example. This is the first example in the text, the lecture, which is on the blackboard. All right. So you have something like this. I think I have a plus here, sorry. All right. So first of all, you can see that you have a common denominator. You have the same denominator in both fractions, right? X squared plus 1. So it's a binomial, x squared plus 1 in both fractions. So in this case, you're just simply going to add the numerator. So you are going to write the same denominator, x squared plus 1, and you're adding x plus x minus 2, and you end up with 2x minus 2, and downstairs is x squared plus 1. Okay, and you're done. This is a prime, this is not a prime. You can extract a common factor too, but you're not going to have anything to cancel with, so the business is done here. You could end up in a situation that you're adding two fractions, that you might end up with the something that is not reduced, and then you have to reduce it, of course. Here is the, so for example, if I have something like this, then I would not have a prime. So if I have something like that, I had to work a little more, because downstairs I don't have a prime, and upstairs I don't have a prime, so I can use a common factor, which is 2, and I have x minus 1, so that's the numerator right here, 2 times x minus 2, and down there I would have x minus 1, x plus 1, and I have a common common factor up and down, x minus 1, so I would end up with 2 over x plus 1. So I make a modification of the first example that is in the lecture. This is not in the lecture. I just made a change to show you that you might end up with a reduction. You might need to reduce. Okay, now when you have a subtraction, you just have to be a little more careful, just a little more careful. So I have, for example, here x plus 2 divided with 2x squared minus 1, and I'm subtracting, and this is x minus 3, and downstairs I have the same denominator, 2x squared minus 1. Okay, so what am I going to do here? You have to be a little more careful here. You are subtracting. You do have the same denominator, so you can write that denominator one more time, 2x squared minus 1, and I'm going to be subtracting numerators. This is the first numerator, x plus 2. The second numerator is x minus 3. And you are subtracting this numerator minus this numerator. You need to do this. And the reason is very simple, because you are subtracting the whole numerator. Now, if you do not do that, you're going to be subtracting 3, but you're not going to be subtracting negative 3. Subtracting negative 3 means adding 3. So that will be a mistake. So you need to do this. because you are subtracting the first numerator minus the second numerator, the whole numerator. And that ought to be always on your mind. So when you're subtracting, this is a possibility of mistake, usually, if you're not careful. Okay? So you have x minus x, which is no x. And then you have a 2 minus 3, which is 2 plus 3. And down there you have the old stuff. Okay? So again, be careful with subtraction. Subtraction of two fractions involves subtracting, if they have the same denominator, involves subtracting numerators. But you need to make sure you're really subtracting numerators, not just a part of it. Right? So again, be careful about it. Okay. Now, when the denominator is different, then you, of course, you have a least common denominator. The principle is very simple. It's the idea is you cannot add or subtract the apples and oranges, right? 3 apples minus 5 oranges, that means nothing, right? You can't do that. The same thing if you have something like this. Right? Or let's say adding. So you have a 12ths, 5 of them, and you have 18ths, 5 of them, and you need to add. So you can just say, you know, the typical mistake people that don't have any idea what they're doing would you know, just add the top and add the bottom, and that is just nonsense, right? Let me give you an idea why that would be nonsense. 1/2 plus 1/2 is exactly 1, right? That's quite clear. If you add a half and a half, you get a whole thing. So if you use this principle, add the top, you get 2, add the bottom, you get 2/4. So 1/2 and 1/2 is equal to 2/4, which is 1/2. So this is just nonsense, right? So you don't do that, okay? What I want to say basically is that the principle is that you need to have apples and apples, the same denominators, if you're to add fractions. So you need to find the common denominator. What's a common denominator? Well, you can find it this way. This is one way of finding it. You divide both of them with everything you can divide with. So you can divide them both with 2, you get 6, you have 9. You can divide both with 3, and you have now 2 and 3. This is the process we were doing to find the greatest common factor. Now, the same process. This is the greatest common factor. The same process will give you the least common denominator. The least common denominator is all of that. So that's 2 times 3 times 3 times 2, which is 36. 12 goes 3 times in 36. 18 goes 3 times in 36. Now, why is that? People do it a different way. So, for example, 12, it's made out of 2 times 6, which is 2 times 3. So you can see exactly the prime factorization of 12. That's it. This is 12, 2, 3, 2. I was dividing 12 with 2 and 3, I get 2. So it's 2 times 2 times 3. The same way is for the 18. I have 2 times 9, and 9 is 3 times 3. So this is what 18 is made of. It's a prime factorization of 18. I have 2, I have 3, I have 3. So this is what you see here. 2, 3, 3. This is 18. I was dividing with 2. I get 9. Divided with 3. I get 3. So 18 is made of 2 times 2 times 3. Right? So the least common denominator is also the least common multiple. So you can find it this way too. It is another way. 24 is a multiple of 12. 12 is a multiple of 12. 36 is a multiple of 12. 48 is a multiple of 12. 60 is a multiple of 12. 72 is a multiple of 12. You can go that way. Further, 18, the first multiple is 18. The second multiple is 2 times 18 is 36. The next one is 3 times 18 is 54. The next one is 4 times 18, which is 72. Da 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 da. Okay, you can see one here, but you can see a smaller one here. And that's what we're looking for. The least common multiple, which is the same as least common denominator, if those are denominators, which are in this case. Okay? So this is one way of finding that. You look at all of the multiples, and find the first one that appears in the both lists. And that's going to be a common multiple because it's a multiple of 12 and it's a multiple of 18. It's also the least one, so this is the next one. And on you go, you can find more, but this is the least one. Why we need the least one? Well, small number, less work. Okay? So you can also see that out of here. What do you need to have so you can cover 12 and 18? You definitely need 2. You need another 2 because this guy has 2 of them. You also need 3, and you need another 3. So you can see here 12, and you can see here 18. So this number is a multiple of 12, 3 times 12. It's also a multiple of 18, 2 times 18. So that's one more way to see that. Okay? One way or the other, you would find that that number that you need would be 36. And so now both of the fractions have to be expanded to 36. So you have a 12 times 3 is 36. 5 times 3 is 15. Again, this is build-up. This is the good old procedure we said we do with fractions often. You build them up. This one goes twice into 36. You got 5 twice into 10. So now you cannot. You're adding and you get 25, 36. And possibly you can maybe even reduce down the road if there is something to reduce. There's really nothing to reduce right here. So this is the end result. So this is what we do with fractions. When you're dealing with rational expression, you will do the same thing. Because rational expression is nothing more than generalized fractions. You have a variable fractions. Okay? So here is an example. I have, there might not be even 2 fractions, it might be 1 fraction. So for example, I have something like this. This is not a fraction, it's just, you can write it 10 over 2 or 5 over 1 if you like. And then you have something like this. So I have 2 fractions here. This is really not a fraction, but you can look at it as a fraction. This is fraction, right? So you can have a fraction if you really want to. So I'm having here something that I want to build up. Okay? I have to build this up to the common denominator. So you have only one denominator to worry about. That's y minus 2. So that's how you're going to build it up. You're going to build up to the same denominator. Y minus 2. Y minus 2. You don't have to worry about the second one. It's already with that denominator. You need to build the first one with that denominator. So how are you going to do that? Well, again, take a look at that. So this one is multiplied with what to get here? With y minus 2. So which means, so this one to get here, you're multiplying with, I shouldn't write x because I wanted you to think about variable, you're multiplying with y minus 2. So the top also has to be multiplied with y minus 2. So you have 5 times y minus 2. Okay? Now my arrows are not needed. This is just for you to see what you're doing. I am multiplying with y minus 2. Okay? So in the next step, I'm going to have to finish this build-up. I'm done here, but I'm not done here. So you have 5y minus 2, 5 times y, 5 times 2. You get 5y minus 10. Y minus 2 downstairs, now you're subtracting. And now you do the same thing we were doing moments ago. You are subtracting 2 numerators. Which means, this is very easy business now. I don't even have to write everything. 5y minus y, which is 4y, and minus 10 stays and I was just subtracting two numerators. Basically, I subtracted the y. And down there I have y minus 2. The end of the story, right? Fairly simple stuff. Well, yeah, okay. I have here, this is not a prime. I can have a common factor 2. But downstairs is a prime and doesn't have a factor 2. Now, this 2 is a term, of course, right? So you don't have a common factor. And what will be left here if I subtract 2 will be 2y minus 5. And the y minus 5 doesn't have anything common with downstairs as a factor. So I'm done. You don't have to do anything further. Okay. Now, more. Here I have another example. I have x minus 1 in one denominator. X minus 1 is a prime, and the other denominator is x plus 2. One more time. To be able to subtract this, I will need to expand both of the fractions. I will need to build them up, because I don't have a common denominator. So the common denominator will be a product of two. This is a prime and this is a prime. The only common multiple you can have, the least common multiple you can have, is just the product of the two. So for example, if you have prime 3 and 5, the common multiple will be 15. It's just 3 times 5. You can't get anything better than that, right? So the same thing here. Prime, the common multiple is going to be a product of the two. So that's what I have to have as a common denominator. So I am building this first fraction up by multiplying x plus 1 with x plus 2. The same thing with the numerator. Remember, you're multiplying with the x plus 2. Parentheses are extremely important. If you don't have parentheses, you're multiplying 3 times x, and then you just have an extra 2 there. That's a mistake. The same thing I'm going to do here. I had x plus 2. I have a x plus 2 here. I was multiplying with x plus 1. So you get to multiply x with x plus 1. Okay? You can see that. You can check that by way of reduction. Right? If you cancel this and this, you get x over x plus 2, which is what you have here. That has to be. Now, you're just simply going to subtract. You have a common denominator. And you're going to subtract the numerators. This is a single term, and that's a single term. So I propose here first subtract and then work it out down the road. The reason why I'm doing it that way, because it's easier. I'm subtracting a single term minus single term, so I don't have to worry about it. I'm going to have to subtract the whole thing. I am subtracting the whole thing. So now you work it out. On the top I have 3x plus 6. You got 3 times x, 3 times 2. And this one I have negative x times x, which is negative x squared. And I have negative x times 1, which is negative x. And downstairs, for a moment, I'm going to keep it factorized. You could multiply if you like, but you might have to do the reduction down the road. So maybe it's a good idea to keep it factored, because you might have to factor it down the road anyway. So, okay, the next line, I'm going to now simplify this. I have a negative x squared. I'm writing that in the standard format, so the top power goes forward. I have a 3x minus x, which is 2x. And I have 6. So you have to just be careful. Count everything you have. This is going to be a prime. It's not going to be possible to factor it. You can try. If you can find a factorization, go for it. But it's not going to be. So downstairs, I'm going to avoid parentheses. You can leave it this way. It's called factor format. If you leave it that way, it's not going to be wrong. It's not going to be wrong. The top in this thing, of course, you have to simplify this because it's not the standard format. This is not a standard format. The bottom, you can leave it factor, or if you want to multiply, you're going to end up with an x squared, and then you have 3x and 2. and this is the end of the story. Okay? Okay, let's make something a little more complicated, just a touch more complicated. So this was when I had 2 primes as a denominator, which was a very simple common denominator, was just simply a product of the 2. Okay. So now I have, the next example is in the lecture is a 3x, and then I have 4x plus 4. And that's not a prime, right? It's a common factor 4 in denominator. And the next one is something like this. Okay. So now I'm going to use this principle. I'm going to find the least common denominator. Okay. So when you're dealing with numbers, you can write all of the multiples of the first one, all of the multiples of the second one, and find the smallest one that is in both lists. But this is not going to be possible because we have so many different options how to multiply that. We can multiply that with 1, 2, 3, 4, 5, 6, but we can also multiply with x, and 2x, 3x, 4x, 5x. We can also multiply with x plus 1, x plus 2, and so on. So that's not an option. So what do you have to do? Well, you have to factor them into primes. So the first denominator here, 4x plus 4, you can factor into primes. And this is the factorization. Now, of course, 4 is not a prime, so I can write it as 2 times 2. That's a factorization into prime. Prime, prime, prime. The second one, the same story. So I have a 3x plus 3. I'm factoring that into prime. Okay? 3 times x plus 1. So these are 2 primes. And now you collect everything so you can have both of them. So what's the least common denominator? Or the least common multiple. Again, least common multiple is the same as the least common denominator. And try to remember this. It's not the same as the greatest common factor. GCF, greatest common factor, is something completely different. Right? LCD or LCM is the same thing. Least common multiple and least common denominator is the same thing. We call it least common denominator if they are denominators. If they are not denominators, we can just call it least common multiple. But in either case, it's always least common multiple. So what do you need? You need 2, you need 2, you need 3. In other words, you need 12. And you need x plus 1. Okay? So again, I'm going to write this as 2 times 2 times 3 so you can see. Yes, this is a multiple of 3 times x plus 1. You can see that here. 3 times x plus 1. Multiple is 4 times. Right? So it's this guy 4 times. About this guy, well, we have a 2 and 2 and x plus 1. So it's 3 times this guy. This one here has an extra 3. That's 3 times this guy. So this is a common multiple. And it's also the least one. Because I do need 2. I do need another 2. I do need x plus 1, and I do need 3. So I need all of them. I can't have anything less. So this is the least common multiple. So now you build up. Okay, the first fraction will be built up to 12x plus 12. By the way, this is 12x plus 12. Or, if you just when I use parentheses, you can write this. 12 times x plus 1. This is 12 times x plus 1. A couple of different ways to write this. But, so, I can write it this way. It's nice to see that. Because then you see what do you need to go from here to here. What do you need? Extra 3. This one is, this one here is 3 times multiplied to get here. Right? Maybe I should write it up parentheses. 12x plus 12. Look, 3 times 4x is 12x. 3 times 4 is 12. You need to multiply the top. 3x times 3. You multiply top and the bottom with the same number, 3. The second one, how do you get from here to here? Well, let's take a look. How do you get from this one to this one? From this one to this one? You multiply with 4. Here's the extra 4. Right? You have 3 and x plus 1, 3 and x plus 1, and you have 4 extra. So you multiply this with 4 to get 12x plus 12. Right? 4 times 3x is 12x. 4 times 3 is 12. So you need to multiply the top with 4. So x times 4. And now you can proceed. What you have here is 9x, 12x plus 12 minus 4x. I'm already writing the result, right? 4x, 12x plus 12 equal 9 minus 4, 5x, 12x plus 12. And you can think about, maybe I can reduce this. The top is 2 factors, 5 and x. On the bottom we have 2 times 2 times 3 times x plus 1. You won't find any common factor to cancel, so this could be left the way it is, because there's nothing better. Okay? One more. Right? So the next one looks a little more complicated. Okay, I have too much of a power here. I need a square only. So x squared plus 3x minus 4, and the next one has x squared plus 4x. Okay? So one more time. You have two denominators that are not the same, so you need a common denominator. And once again, you'll find a common denominator by factorizing denominators. You can see what you need to have as the least common denominator. So the first one you can factor x squared plus 4x. You can factor x. So it's x plus 4. Okay? This is a prime, this is a prime. You cannot factor them any further. Okay? The second one, or should I say the first one? This should be the first one. But I just choose the this one as a simpler one. The second one, this one here, you can factor as, you should know the factorization here, as an x plus 4, x minus 1, right? You need two numbers whose product is negative 4 and whose sum is 3, and there will be 4 and negative 1. So that's the factorization. So now you are looking for the least common denominator, or the least common multiple. What do you need? You need an x. You need x plus 4. You need to have all of the prime factors of the first one. You also need to have all of the prime factors of the second one. You already have an x plus 4. Now you need an x minus 1. So now you have them both. Okay? This one here, this guy. This one here is right here. Multiply with x minus 1. This one here, this guy. It's the same thing here. It's right here. Multiply with x. So that's how you have to build it up. So you can clearly see what you need to build up. So now you have the least common denominator for both of the fractions. So it is x, x plus 4, x minus 1. And you're going to be adding the one with the same denominator, because that's the way to add. You need to have the same denominator. So again, this is here, right here, x plus 4, x minus 1. What's the news? X. So going from this guy to this guy, you're multiplying with an x. So you need to multiply the top with an x. So again, you can see that by going in the reverse, if you reduce the common factor, you divide with x, and with x you cancel the common factor, you have 1 over x plus 4 x minus 1, which is exactly here. Right? X plus 4 x minus 1. The second one, This guy, what is it made of? It's made of this. Okay? Going into least common denominator, you need to multiply with x minus 1. You see, you have an x, you have an x plus 4, x plus 4, you don't have an x minus 1. So going from this one to this one, you're multiplying with x minus 1, which means going from this one to this one, you are multiplying with this guy. This is x squared plus 4x. You're multiplying that with x minus 1. So the top 2 has to be multiplied with x minus 1. Do not forget parentheses. You're multiplying 2 with x minus 1. If you omit parentheses, you're going to be multiplying only x. Right? And that's a mistake. Now it's simple. We're just going to finish this by writing the common denominator and adding the numerators, dx and this here. Keep the parentheses until you're quite sure that you know what you're doing. The next line, x, 2 times x plus 2x, 2 times negative 1, negative 2. One more time. I'm still writing that in the factorized format because I don't know, maybe I will have to reduce. Okay? Now the question is, I have here an x, excuse me, 3x. So instead of writing the whole new line, I'm just going to add x plus 2x, which is 3x. Okay? Prime, 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 prime. 3x minus 2 is a prime. You cannot factor it. And they have no common primes. Right? This is only 1. This is 1, 2, 3. Nothing to cancel. You can leave it this way. That will be called factorized format. Or you can just simply multiply the bottom. And so what is the bottom? The bottom is this guy multiplied with an x. This is an x plus 4x minus 1 multiplied with an x. Right? X plus 4x minus 1 multiplied with an x. You can just increase the powers of x here. So you have 3x minus 2. And the bottom you have x cubed plus 3x squared minus 4x. You can multiply this and get the same thing. All right? Looks good because I don't have any parentheses here. Or you can leave it this way. I always get this question. Oh, Professor, can I leave it this way or should I do this way? My answer to that is very simple. If you have any questions about how to multiply, you're not quite sure whether you know to do that or not, you're afraid that you're going to make a mistake, then by all means go and multiply. Because the practice will teach you. With the practice you will gain. Okay? But if you know how to multiply, you have no problem with that, then you can leave it this way. Who knows? Maybe you will need to reduce it down the road, so you want to keep it in a format that you can use for reduction down the road. Okay? So if you're afraid of doing something because you're afraid of making a mistake, then do it. You see, mistakes are not costly. I mean, not while you're practicing, right? The mistakes could be costly if you're doing that in the test. You have to be a little bit worried about that. But while you're practicing, the mistake is not costly. But it will teach you something. Trying too much stains on the board. Alright. My razors are not good enough to erase everything. Okay. Alright. More. Let's have one real bad example. Well, this is actually not so bad. 2x minus 8. It's not factored because there's a common factor 2. Downstairs I have 3x squared plus 8x plus 4. That's the first fraction. The second fraction is I have x plus 3. And downstairs I have a 3x squared plus 5x plus 2. Okay? So again, the denominators are not the same, which means you cannot add. You have to find the common denominator. So the common denominator is by looking at the factorization of both denominators and assembling whatever you need to get a common denominator. So 3x squared plus 8x plus 4 has to be factorized. You have two parts. You have an x and 3x. Right? X times 3x. It's a good old story we had before. And I can factor 4, 1 times 4, 4 times 1, or 2 times 2, whichever works, right? You have to try all three, because that's a trial and error. Or you can go that AC method, whatever. You need to know that. I'm going to tell you that this is just 2 and 2. So I already know it's not 1, 4, it's not 4, 1, it's 2 times 2. You can check it out. 2 times 3x is 6x, 2 times x is 2x, and 6x and 2x is 8x. The middle term is indeed 8x. So that's a simple factorization. This one here, 3x squared plus 5x plus 2 factorizes also into x and 3x. But now what is the left over here? A 1, 2 or 2, 1. That's how you get 2, right? 1 times 2 or 2 times 1. Okay. Now I'm going to tell you again that I know that this is going to be 1 and 2, not 2 and 1. But you should try both to make sure that you have that correctly, right? 2 and 1 would give you something wrong. It will give you 7. No. 1 and 2 will give you 5 for the middle term. 1 times 3x, 2 times x, that's 3x and 2x, which is 5x right here. This is correct factorization. So now you know what you need. Least common denominator is made of these two. You had to have them both, because that's the way to have the first one. Now the second one, you have this piece right here, but you don't have this piece, so you have to add that. So now you have both prime factors for the first one, right here, and both prime factors for the second one, right here. X plus 1, 3x plus 2. This is the least common denominator. It has to have all of the prime factors for both of them. And it doesn't have any excess, nothing more than that, which means it's the least one. So now you work this out. You're gonna have to, I'm gonna squeeze this a little bit to have a little more space. You're gonna have to expand that into two fractions. They have the common denominator, this thing here, x plus 2, 3x plus 2, x plus 1. Plus here, and the same thing repeats again here. Common denominator, right? Okay, so now the build-up. You're going from this piece to this piece, and this is right here. So you had x plus 2, you had a 3x plus 2, x plus 2 and 3x plus 2. So how do you get this? You were multiplying this with x plus 1. Again, take a look. You have this, you had this, you multiply with x plus 1. The top had to be multiplied with x plus 1. So you have a 2x minus 8 to be multiplied with x plus 1. The second one, this piece here, it's x plus 1, 3x plus 2. That's right here. So you're expanding, you're multiplying this guy with x plus 2. So you get from here to here by multiplying with x plus 2, which means the top, x plus 3, has to be multiplied with x plus 2. And again, you can check this out by doing reduction. If you reduce the common factor here, you're going to have 2x minus 8, which is right here, and now you're going to have x plus 2, 3x plus 2, which is this guy. The second one, if you cancel the common factor x plus 2 and x plus 2, you're going to have x plus 3 on the top, which is right here, and you're going to, on the bottom, you're going to have 3x plus 2, x plus 1. 3x plus 2, x plus 1 is this guy, right here. So this is a correct build-up. Okay? So now you're going to continue by adding. So you have a single denominator, x plus 2. I'm still writing that in the factor format. I'm not multiplying. And on the top you have 2x minus 8, x plus 1, plus x plus 3, x plus 2. Now you say, oh, Professor, can I leave this? No, you can't, because it's not a factor format. On the bottom it is, but on the top it's not. This piece is factor, then you have a sum, then you have the second piece is factor. This is disorganized. You need to organize this. You need to write it in the in the form that you can simplify. So multiply the first. 2x times x is 2x squared. 2x times the FOIL, right? 2x times 1 is 2x. Negative 8 times x is negative 8x. Negative 8 times 1 is negative 8. So that's just the first one. What do we have with the second one? X squared, 2x, 3x, 2 times 3 or 3 times 2. Okay? On the bottom, I'm still writing this. X plus 2, 3x plus 2, x plus 1. The top. I need to work this out. What do I have here? It's not going to be that long. Once I simplify, it's already a little shorter than I thought. Okay, I have 2x squared and x squared. I have a 3x squares. Now you know you're done with those. You can use something like that, strategy like that. Don't erase, because if you erase and you did something incorrect, you're going to have to go back and you won't see what you erased. That's a problem, right? Then I have the x's. 2x minus 8x is negative 6x plus 5x is negative 1x. So I'm done with the x's. This was negative here, right? So make sure. It's very easy to make a mistake if you disorganize. You don't know to write things properly. And what is left here is a couple of numbers, 8 and 6. I have 14 here. Uh-oh. I made a mistake, right? You know what mistake I made here? I read this as a plus, which is not. You see, again, being disorganized and not writing nicely, I didn't notice I have a minus here. So I have minus. Negative 8 plus 6 is negative 2. Okay. So again, there's a reason why you need to be tidy. You need to write it in a nice way so you can read it. Anytime you start writing the stuff, scratching around and erasing and putting stuff one after another or one on top of another, you're going to have a problem reading that. Okay, so this is the top. At the bottom is, what do I have? X plus 2, 3x plus 2, and x plus 1. Now, okay, I guarantee that this is prime, prime, prime. On the top, I'm not so sure, right? As a matter of fact, it isn't a prime. So if you stop here and the direction that you need to do here would be, it says, add and reduce to the simplest form. Then you're not done, because this is not the simplest form. The one on the top could be written as a product. It isn't a prime. You have an x and you have 3x, and you also have negative 1 or 2, or negative 2 and 1, or positive 1 and negative 2, or positive 2 and negative 1. 4 different options, and I believe it's going to be this. Okay, I'm I'm not guessing, I'm actually seeing that, but the for you it should be, you have three options of trial and error. You should write it down, make sure you check every one of them, and then you're going to find this one. So middle term, negative 3x, positive 2x. Positive 2x, negative 3x is negative 1x, right here. So that's a correct factorization. Downstairs, I have x plus 2, 3x plus 2, and x plus 1. And only now you can see reduction, this one and this one. And of course, this and this is not the same, right? It's obviously different. So you can write this as x minus 1 on the top, and on the bottom you can either keep this x plus 2, x plus 1, or you can just simply multiply. And if you multiply x plus 1 and x plus 2, you're going to end up with an x squared plus 3x plus 2, which is the end of the story, without parentheses. Again, somebody's going to ask, you know, oh, should I multiply this and this, or can I just leave it that way? You can leave it that way if you want to have factor form, but if you're not sure how to multiply because you're afraid you're going to make a mistake, then by all means multiply, because you're going to get in that practice. Okay? All right? Now, my next example is the worst one of this story. Because it requires you to add three things. As a matter of fact, you need to add two of them and subtract one. So the first one says something like this, and a variable is not an x, it's an a. So what, right? Plus and then you have to subtract the third one. So one way of doing that would be, you know, you work with the first two. Once you're done with the first two, whatever you get, then you have to subtract the last one. Or, as a matter of fact, you can work with all three at once. You do have 1, 2, 3 different denominators. 1, 2, 3, they're all different. So you need to find the least common denominator for all three. The first one is a minus 4, which is equal to a minus 4. There's nothing much about it. This is all de facto. You can say, why am I writing that? You know, I don't need to. I just want to show you that this is the prime factorization. 2 is prime factorization of 2. Okay? The next one, it's not prime, because you can have a common factor, which is an a. And then you have an a plus 5. So now you have an a squared and 5a, which is exactly what you have here. So you have two primes. And the third one, I made it that way, has a prime factorization into a minus 4 and a plus 5. Okay? Easy one. You multiply negative 4 and 5, you get negative 20, and you add negative 4 and 5, you get positive 1. It's exactly what you have here. So the least common denominator, or the least common multiple, should have an a minus 4 as a factor. Should be multiplied with a plus 5. Two more factors. Is there anything else? You have an a minus 4 right here, a plus 5 right here. So these are the three. So this one contains the first one, a minus 4, as a factor. It's a multiple of the first one. It contains the second one right here. The second one right here. It's multiplied with a minus 4. And it contains the third one right here. That's the third one. These two guys. And you have an extra a. So it's the third one multiplied with an a. So now you know. What's the common denominator, right? So, the common denominator here. Let's go. The first one, I'm going to separate this story. This is a scrap paper which you're looking for the common denominator. So I'm continuing this story here. So I'm having the first one, a minus 4, a plus 5, that's a common denominator. I wrote them in a little bit different order. I kind of don't like the a to be in the sandwich here, so I'm writing that in front. The second one, also a minus 4, a plus 5, and the third one, I'm trying to squeeze, but I need to still be organized here. A minus 4, a plus 5. Okay, so that's a buildup of the denominators. So what about numerators? I have an a here, a minus 4, it's right here. So I was building it up by multiplying with an a and a plus 5. So the a has to be multiplied with an a and the a plus 5. Don't forget parentheses. The second one, on the bottom, I had a and a plus 5. This is made out of a times a plus 5. So I have this a and a plus 5, but I don't have a minus 4. So the top 5 needs to be multiplied with the 8 minus 4. Now this is done with the second one. The third one, on the bottom I have a minus 4 and a plus 5. A minus 4 and a plus 5. This is the guy right there. Denominator factorization. I have it here and here. What's missing is an a. So the top 11a minus 8 has to be multiplied with an a. Notice parentheses. If I don't have this parenthesis, I will only multiply 8 with a, and that would be a mistake. I need to multiply the whole thing. The 11a minus 8 with an a. Very important thing to remember. We are multiplying the whole numerator with an a, not just a piece of it. So if you do not include parentheses, you're going to make a mistake. You're going to be multiplying only, the last one if you're doing that from behind, or the front one if you're doing that from front. You need to multiply the whole thing. Okay? Now you can work this out. What do we have? A minus 4, a plus 5. What do you have on the top? You have this stuff. A times a plus 5. I'm not multiplying anything. You can say, well, why don't you just make a square? Yeah, I'll do that later. The second one and the third one. It's a one term, so the minus is not going to mess up anything if I just keep it the way it is. One term, right? Now the work. A minus 4, a plus 5. I'm going to multiply now. A squared times a is an a cubed. A squared times 5 is 5 a squared. That's the first one. The second one is also easy. 5a minus 20. 5a minus 20. Well, the third one is not that hard either. 11a times a, it's 11a squared with a minus. And I have negative 8 times a, negative 8a with a minus. Don't forget this negative. So anything you do here, you multiply, you're going to have to change the signs. So I have 11a squared, change the sign, negative 11a squared. I have negative 8a, change the sign, positive 8a. And finally, you can work this out. You still have to put it in the standard form. So on the bottom you have, I'm writing that in the factored format. You could multiply if you like. I will at the end. On the top I have the cube. Done. Squares. This one and this one. 5 minus 11. Done. Try to be organized. Nice organized. A's. 5 and 8. 13. Done. And the only thing left is negative 20. Okay? Like you say, is this done? Yeah, it is. It is. You will not be able to factor this. You try. I'm claiming you can't. It's a prime. You can try yourself to see if you can get this. If you leave it this way, it's all the factorization. This is a prime, 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 prime. It's factorized into prime. Or you can multiply the bottom so you don't see any parentheses. If you want to do that, it's not really that hard to do that. So on the top would be cube minus 6a squared plus 13a minus 20. On the bottom you would have basically this guy, a minus 4, a plus 4, multiplied with a. So you have an a cube on the bottom, a squared minus 20a. Okay? You check yourself, multiply this. So that looks nice, sort of. No, not really, but as good as it gets. I was just getting rid of parentheses. So you can leave it this way, factors format, or you can multiply and get it that way, which would be simplified format without any parentheses. Okay? All of this is in the lecture, right? So I want you to work on that. Okay? Now, the next thing, so I'm done with the addition and subtraction. What else you do with fractions? Well, sometimes, very often actually, you have to work with what's called complex fraction. And complex fractions are things that have fractions within the fractions. And actually it's not so scary. You just need to know how to read it. So I have a couple of examples. So I'm going to give you the first one. X minus 5. So this is the story about the complex fractions. Or you can call them compound fractions or compound rational expressions. So what I have here is one fraction and then another fraction within a fraction. So you might wonder, what the heck am I going to do here, right? It looks like something really complicated. It isn't. Every time you face the problem that you've never seen before, you just have to think about what you have. Maybe you can connect it with something you know. If you can't, then think of what you have here. What do you have here? You have this fraction. This is the last thing to do. Divided with this fraction. So you basically have fraction divided with fraction. So if you just rewrite it that way, it becomes a simple problem. And now you have the same story we had when we were talking about division of rational expression. We turn it into multiplication by flipping the divisor. And now before you multiply, you're going to reduce. Again, so let me just underline the strategy here. So this is a fraction, this is a fraction. They are divided. This is a line of a division. So you are dividing this fraction with this fraction. The longest line is the last division. Every rational fractional line is a sign of a division. Now to be able to work this out, you have to factor it, so you can reduce the stuff, right? So you have x minus 5, 1 prime, difference of two squares, x minus 2, x plus 2, that's a special product. X plus 2, another prime, another difference of two squares, x minus 5, x plus 5, the common factors, x plus 2, x plus 2, x minus 5, x minus 5, and this scary thing in the beginning is actually a very simple thing. On the top you have nothing left, which is 1. On the bottom you have an x minus 2, x plus 5, right? I said that last time. You're going to have to remember that when you are canceling every factor in the numerator, you have 1 left, because you're not really canceling anything. You are dividing. So when you're dividing with everything, you got 1. 7 divide with everything, with 7, you get 7 divided with 7, it's 1, right? So keep that in mind. Do not lose this. So that's easy stuff, right? I'm going to give you one a little harder, okay? Just a touch harder. Compound complex fraction. Compound. I should really call it compound rather than complex. Complex is a word we use for something else. You might have noticed we have some lecture. Compound fractions. Okay, so I have another one like this. And so lots of people don't understand what they have to do here. They're just going to cancel 1 over a, 1 over a, and you get negative 1 over 1. You're going to conclude this is negative 1. That's a heavy mistake. That is not something you can do because this is not a factor, right? It's a term. You're subtracting, you're adding. So you cannot cancel it. So you say, oh, okay, what am I going to do now? Well, if this would be a fraction here, if the top would be a fraction and here would be a fraction, you'd be dividing fraction with fraction, so you would turn it into division, flip the divisor, and do the same thing we did moments ago. But you don't have a fraction. So you need to have a fraction here. Now that's not really that hard to get. You're adding 1 over a and you're subtracting actually 1 over a and 1. How do you do that? You have to have a common denominator. 1 over a. And what is 1? A over a. Right? You're building this up. This is like 1 over 1. You need to have an a down there. You multiply with an a, multiply the top with an a. That's a formality. But the idea is a over a is 1. So now you are adding, subtracting. 1 minus a over a. That's what you have on the top. Now it's a single fraction. 1 minus a over a. On the bottom, you're going to do the same thing. Okay? So this is a scrap paper. So on the bottom I have 1 over a plus 1. The same thing. 1 over a plus a over a is 1 plus a over a. Common denominator. Add numerators. Okay? That's that extra step needed here. Going from this to this. I'm creating a fraction on the top, fraction on the bottom. Now it's easy stuff. It's this fraction on the top divided with this fraction on the bottom, which is multiplication now. So I'm going to erase this to mix up anything. 1 minus a over a time a over 1 plus a. Okay? Common factor. Common factor. Because you multiply the whole thing here with this guy. So this is a factor. You multiply this guy with this whole thing here. So this is a factor as well. Okay? There's only a 9 here. It's just an a. Okay? So I have what is left. 1 minus a. Down there. 1 plus a. Very simple stuff. Don't read this as a 9. Sorry. A looks like a 9. That's this. Okay? So this is a simplification going from compound fraction. There's a fraction within the fractions. Fractions within fraction to something that's just a fraction. Alright? Give you another one. One more example. This is the worst one. I come up with something really nasty looking. I actually have minus here. I want to have something like a factor. And down there I have the two fractions. You can say, whoa, this is bad. Actually, it isn't. The biggest number I have here is 6. They're all integers. I don't have anything with floating point, right? So it's not so bad. It could be a lot worse. The biggest number here, the whole thing I have is 6. So this is not really a hard thing at all. Well, what you have here is a fraction, which is perfectly fine, divided with the difference of two fractions. So you don't have a fraction divided with fraction, which would be easy. You have a fraction divided with the difference of two fractions. So you need to resolve this first, this thing here. So you use a scrap paper. 4 over x plus 2 minus 2 over x minus 3. Common denominator, 2 primes. X plus 2, x minus 3. So I'm working on a scrap paper. I'm just doing this guy here. I'm not doing the top. The top is already good. It's a fraction. I don't need to work this at all. Looking good. The bottom I have a problem. I need to make a single fraction. So common denominator. And now, this is multiplied with x minus 3. The top had to be multiplied with x minus 3. This is multiplied with x plus 2. The top had to be multiplied with x plus 2. Okay? Another mistake I should never make is this minus is a minus here, right? Can promote it into plus for no reason, right? Cannot promote it into a plus. Alright, so now work it out. So I have 4x minus 3 minus 2x plus 2. And down there I can write x plus 2, x minus 3. A little more work. I have a 4x minus 2x, which is 2x. What else I have? Negative 12, negative 4. You multiply everything carefully. But I do have negative 12, negative 4, which is negative 16. X plus 2, x minus 3. That's it. Single fraction on the bottom. So, let's continue. Down with the scrap paper work. You keep it around. You have scrap paper, keep it around, because you might want to have to go back and check. Maybe you made a mistake. This on the top is 2 over x squared minus x minus 6. Keep on promoting minuses into plus. On the bottom I have dotted 2x minus 8. Oh, I'm already factorizing, right? You can see 2 and 2, so it's 2 times x minus 8. And this piece here, x plus 2 x minus 3. What I'm saying here, I could have written that here. I have 2x minus 8, and then there I have x plus 2 and x minus 3. So that's what I'm copying right here, instead of this guy. So now I have a fraction divided with a fraction. Okay? I'm gonna save. I'm totally confident this on the bottom is completely correct, so I'm going to erase it. You should never do that. Certainly not if you have a scrap paper. I should have another board, right? I can keep another board around and then work that out. So now I have the division here, which is the top. Divided the bottom. Okay, I'm not going to write the whole new line just to turn it upside down. I'm going to turn this upside down. I'm just going to write it right here. Upside down. And again, I'm not going to write the whole new line to factor this one. This is now multiplication. I'm going to also factor this one. And guess what? It's x plus 2 and x minus 3. And that's an easy to see. You need a product of two numbers to be negative 6, negative 3, positive 2 and sum to be negative 1, which is same thing. So it's a peanuts stuff, right? And all of a sudden, look at that. Common factor, common factor, common factor, common factor. I made it that way. Common factor, common factor. Everything on the top has been cancelled out. I just have a 1. And on the bottom, the only one thing left is x minus 8. X minus 8. Right? So this nasty thing looking here, that will be a big problem if you get this in calculus and you have to work it out, you know, do something with that in calculus. And then all of a sudden you get such a small, simple thing here, which will be much, much, much easier to handle. Right? That's the point of knowing how to work with compound fractions. So again, the basic idea is, if you have a compound fraction, that is fraction within a fraction, you have to somehow complete the business so you can have fraction over a fraction. And then you turn it into division. Now you could also have a fraction within a fraction within a fraction. Well, okay. So select one that would only have a fraction within a fraction and work that one until you get it simpler. And then go back again, right? I'm not going to bother with problems like that, but that could be, you know, there are plenty of nasty algebra you can have here. Okay. What else I want to talk today about? I want to talk about equations that involving rational expressions. Very important topic. Okay? I'll give you one that is very simple and it will not create any problem for you, but it is something new. So equations. Okay, what's new here? The new thing here is the old thing is you have an equation. The new thing here is that this equation has fraction rational expression in it. This is not just a fraction, it's a rational expression. You have an x in denominator. So what do you do when you have an equations with the fractions? In the past, we said it many times, what you really need to do is to get rid of denominators. So you find the least common denominator, there's only one here, the x, right? And then you multiply the whole thing with that. The whole thing gets multiplied with the denominator. Then you can say, oh, I'm done. Well, not quite. You need to remember that we had a story of equivalence. When you are changing one equation into another equation, you want to have the same amount of truth in that new equation as in the old one, which means exactly the same solutions. That could be accomplished only with 3 steps. One of them is you could add and subtract the same number to both sides. The second one, you can multiply or divide with the same non-zero number. And the third one is you can replace any part of the equation with the identical, any algebraic expression, any variable expression in the equation with identical variable expression. Right? Those are 3 rules that you could use. When you are multiplying with this number, you could possibly be multiplying with a 0. You don't know whether this one is 0 or not. So the second rule, which says you can multiply both sides of the equation with the same number, it has to be with the same non-zero number. And you don't know whether this one is 0 or not. So we're going to say this. We're going to put here an asterisk, and we're going to check the stuff at the end. If x turns out to be 0, this is not going to be valid, which means we will have to check the solution. It's not going to be valid because we are in this step, we would violate the principle of multiplying with non-zero if x is 0. Okay? But this is not a big of a problem. Why it's not a big of a problem? Because multiplying with 0 will not lose the truth. It could add it. Right? What am I talking about? Well, 5 is equal 5. If you multiply with 0, it becomes 0 is equal 0. True before, true now. So truth is not lost. 5 is not equal to 6. So this is false. But if you multiply both sides with 0, you get 0 equals 0. It becomes true. So multiplying with 0 gains the truth. You're increasing the truth of the equation. That was, in this particular case, completely false and becomes completely true. In general case, you could be adding extra truth, extra solutions. So you have to be careful. Every solution you get in the end has to be checked against the equation that you have in the beginning. It has to be the solution of that equation, not a solution of some equation you have at the end, because you might have a different non-equivalent equation, right? So this will have to be checked. Now you can do the rest. You multiply this side with an x, you get an x plus 1 times x. You multiply this side with an x, you get 12. Just cancel the denominator. What you have here is an x squared plus x. I put this one on the other side, I get negative 12. Result is trinomial on the left, 0 on the right. The next step is a 0 product property. I have a 0, I need a product. X plus 4, x minus 3 equals 0. Now I have a 0 and a product. The next step is the two cases of the 0 product property. Maybe this one is 0, or this one is 0. In the first case, x is negative 4. First solution, number 1. In the second case, x is equal 3. Second solution, number 2. Now you need to remind yourself, I have to go back and check whether these two guys, 1, 2, are the solution of this equation. They are. If you plug in negative 4, you're going to have negative 4 here, plus 1 is negative 3. You're going to have a 12 divided by negative 4, it's going to be negative 3. Perfect. I'm mentally checking the solution. The same thing with 3. 3 plus 1 is 4, 12 divided by 3 is 4. 4 is equal to 4. You could also check it easily. Is this 0? No. Is this 0? No. So this step was okay. That's important. Okay? You're going to say, what's the whole stuff? And it's just blabbing, and you have this asterisk here that play no role at all. Okay, let me give you an example when it's going to play the role. So you have to check it. I have one that looks like this. I'm making a nice example that doesn't have big numbers in it because I don't want to really work too hard. I'm lazy. Okay, so again, common denominator. This will go the same story we had today a couple of times, or a number of times already. The common denominator is actually this guy here. So the common denominator is x minus 2 is x minus 2 prime, x minus 4 is x minus 4 prime, and x squared minus 6x plus 8 is equal to the x minus 2 times x minus 4. And the common denominator is x minus 2, x minus 4, which is x squared minus 6x plus 8. You can check this out because you just have to check the middle term basically. Negative 2 times negative 4 is plus 8, of course, and then you have negative 2x, negative 4x, which is negative 6x. So, yeah, that third denominator is actually the common denominator. So now, to get rid of the denominators in an equation, you do multiply the whole equation with the common denominator. So you're going to multiply with the x minus 2 and x minus 4. That's this guy. The whole equation will be multiplied with least common denominator. You're multiplying with the whole equation with the unknown number, and that number must be non-zero. So you are putting asterisk mark there to make sure that at the end of the story, whatever you're getting will not make this 0, because if it does, then you're violating the principle of multiplying with a non-zero number, because you're multiplying with a 0. Or if you want to be more safe, you actually, whatever you're getting, you should check here versus the against this equation, because it has to be true for this equation, not for anything else you get down the road. So okay, so now you're multiplying this piece with this piece. So you're multiplying, you're canceling x minus 2 and x minus 2, and you end up with an x time x minus 4. This is what happens when you multiply this guy with this guy. You cancel x minus 2 and x minus 2, you multiply x with x minus 4. The second one, now you multiply this guy with this guy. You will cancel x minus 4 and x minus 4, and you're going to multiply 1 times x minus 2. So you're getting this, right? I could use parentheses, I don't need to. And now this is right here. You're multiplying this guy with all of that, you're just getting 2. You're canceling the whole thing, up and down, right? Okay? Now notice how much easier this became. This became much easier. So I'm going to have x squared minus 4x, multiplying the first. And the second one, I'm just simply going to write an x minus 2 equal 2. Okay? The next step is the zero product property. I need 0 and I need a product. Okay? This stuff here is an x squared minus 3x, this piece and this piece. I have negative 2, this 2 goes here, becomes negative 2, so I have negative 2, and this negative 2 is negative 4 equals 0. The first step, I have a 0. The second step, I need a product. Okay? This piece splits into, very easy, x minus 4, x plus 1. Okay? X squared, negative 4, the middle term, negative 4, positive 1, negative 3. Okay? So you have 0 product. Property is the first solution when this guy is equal 0. That makes it x is equal 4. Right? How can you get this guy equal 0? So I should write it, but I don't have any more lines, so I'm just going to keep it short. X minus 4 is equal 0, that means x is equal 4. That's your first solution. Or the second solution. Right? You know what the meaning of solution is, right? They cannot be bought at the same time, but they're both good solution. Right? You cannot date 2 girls at the same time, but you could date either one of them. The same thing, the same story here. Okay? The second one, x2 is equal negative 1. That's your second solution. So you can say, oh, perfect, I'm done. Nothing else to worry about it. I found 2 solutions of this equation. No, you didn't. Now here is a problem. This is not a solution. Why? Because it makes this 0. X minus 4, if x is 4, makes this 0. So you're multiplying with a 0. Plug in 4 here. You will have something here, 2, undefined, undefined. So you say 2 plus undefined is equal undefined. That's not true. This is like saying, you know, oh, that person I don't know is the same as that person I don't know. You can't have that. Undefined is never equal to undefined. Okay? So that is not a solution. We call this extraneous solution. As an extra solution that you added on the way. And it became a solution here. It works perfectly fine here. If we plug in 4 here, this will be true. But it doesn't work here. Because this step has been violated. I mean, that step violated the property that you cannot multiply with 0. Or you should not multiply with 0. So 4 is a solution everywhere you go from here. This equation, this equation, this equation, this equation, all have 4 as a solution. But this one doesn't. Again, you check that out. Minus 1, that is a perfectly good solution. Again, it doesn't make 0 here. -1, -2 is -3, -1, -4 is -5. Perfect. You're multiplying with +10. -2, 10. Oh, excuse me, 15. -3 times -5. You're multiplying with +15, so you're perfectly okay. So if x is -1, this is not 0. You're multiplying with non-zero number. You can check it also here. I have to work it out. I mean, -1, plug it in here, plug it in here instead of x, plug it in here. It will turn out to be the same on both sides. I think it's 215 on both sides. 2/15. You try it. You check it out yourself. But again, I'm saying that this works. This is a solution. It's solution here, 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 and here, and solution here because it doesn't violate multiplying with non-zero here. You're multiplying with non-zero. This one is not solution. It's solution here, 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 and here, but it's not solution here, which makes, I'm saying, this is not equivalent as this. This one has a one solution, this guy. This one has a two solution, this guy and this guy. They're not equivalent equations. Important thing to know. But it's not a big problem because this one here just have a lot more truth to it. It has two solutions as opposed to one solution, which is the only solution this one has. Okay, multiplying with a 0 could add the truth. One good thing about that is you don't lose the truth. If it was true before, you multiply with 0, it's still true. So multiplying with a 0 only could increase the truth of your equation. You gotta remember that. Dividing with 0, that's a completely different story. You're never gonna do that. Okay? So you have to keep this in mind. Again, when you are working with the equation involving rational expressions, you are going to multiply with the least common denominator to get rid of all of the denominators. And that way you're going to get rid of the whole rational expression. You're just going to get a polynomial equation. But you're going to have to be careful, because when you're doing that, you might be multiplying with 0. So everything at the end you got, you have to check against the original equation, because that is where it has to be true. Not at the end, in the beginning. So these two, this one is, this one isn't. Again, we have a name for this. We call this extraneous solution. As a solution added, extra, not the original one. Right? Now, I complete this story about rational expression. So you have a large homework on rational expression. I suggest you work on that homework as soon as you can to be fresh. We are closing toward the end of our semester. You have no time to waste. You have no time to delay. And this is not a small homework. So you're going to have to work this homework out. The next time we meet, we're going to be talking about radical expressions, something new, right? So that's going to be our story for the lecture on Wednesday or Thursday, whichever class you have, all right? So I'm going to stop the story here, and I leave this stream for you to watch.